Hello everyone, welcome to our new video. So in our last video we measure our soil element. So today we will create step, we will assign interactions and loads, and finally we will run our problem, and we will also assign the boundary conditions. So let's start. So first of all, go to steps. So two steps are involved here. One is gravity and another one is soil pooling or pipe pooling. So it depends on your problem. So first of all, for the steps, we have to create steps. I will call the first step as a gravity. And it's a dynamic implicit quasi-static type of problem. Continue, so nonlinear geometry uh, on, which will account for the nonlinearity of the problem, and it establishes the equilibrium in each steps based on the current nodal positions. Then incremental size minimum 10 to the minus 6 I think is fine. Then copy the initial will also 10 to the minus 6. How many increments? 1 0 4 0 6. I think 60 is fine. Yeah, and keeps the other thing unchanged. The solution technique is full Newton. Yep, all good. Then creating another step, which will be the soil pooling or pipe pooling depending on the problem. So this is the case for the soil pooling. So create, I will name it pooling. The same dynamic implicit steps increment. I will uh, reduce the increment size by one order comparing to the gravity, 10 power minus 7 the minimum one. And initial means I want to start the step using this based on this increment size. And how maximum number of increments, again probably 7 zeros after one is fine. 1 4 6 7, perfect. And now the solution technique Newton, full Newton here as well. Okay, so step is good now. So now the history output. So okay. Okay, so history output. So these are the predefined history output. So there are also some other options available. So depending on your queries, you can select them. So I will keep them as pre-selected, and in every one increment I want values. Okay, it will automatically be propagated in the next step, so it's fine. Then history output energy, I just want to know the total energy of the model from history output, and every one increment is fine. Okay, good. So I'm good in steps. Now I have to assign the interaction properties. Go to interaction, create the interaction property, then create here. It's the contact. Okay, so from the tangential behavior I will select the penalty, and the friction coefficient, it depends on your problem. I will set the value as 0.612. Shear stress no limit, and elastic slip for this simplified problem, keep it as it is. Okay. Then the normal behavior, hard contact, so no penetration of the soil nodes to the pipe is fixed, and no separation is allowed after contact. Yeah, all good here. Okay, so I have created the interaction. Now I have to sign it, right? So before assigning it, two things I have to do. One is selecting the pipe surface and selecting the soil surfaces. So how to do that? I will go to pipe, then surfaces. I will name it pipe outer surface. Continue. From here I will select angle, then I will click here, so all the pipe outer surfaces are selected, right? Done, perfect. Then I will go to soil surfaces. I will call it soil interacting surface, and I'll go here and the inside surface of the soil, right? Continue. Biangle is automatically here. So what happens if you select individual, you click here, only one surface is selected, so one part of the surfaces are selected. So click a biangle, then click here, the all surfaces will be selected. So done. Okay, now I have to go again interaction. I have already created the contact. Now I have to assign this, right? So go to create, go to the initial step, then general contact, continue. Whatever the interaction property I have created, I'm assigning here. Then contact formulation, master slave. So in this problem, my pipe outer surface is the master one and the soil is the slave surfaces. If you go through the documentation, you will learn detail about what is master and what is slave. So I'm not explaining this in the video. First surface is pipe and first surface is slave, so I have to change it as a master, right? Okay, then okay. Okay, so my interaction is done, right? So my interaction is done, step is done. Now the load and boundary conditions, then I'm good to run the model. So go to load. So the first load will be the gravity one. I will click here, then create gravity. I will name it gravity load, then gravity, then continue. So I want the gravity for the whole model, both the soil and the pipe, in the negative y directions. So it will be minus 9810 millimeter per second square based on my units I'm using. So amplitude, I will create a tabular, I will create a tabular amplitude. So at time 0, 0 gravity. At time 1, which is the full time step, the amplitude is 1. So full gravity will work, right? Done. So only one load is here, so it's fine. Now the boundary conditions. So boundary condition is depending on your problem. So my specific problem, so I'm trying to simulate this kind of thing. So pipe is fixed at one end and we are pulling the whole soil masses, and the other end of the pipe is free. So for this specific problem, what we need to do is the first thing we need to do is okay, we have a boundary, uh, we have a fixed soil box in our lab, so we are simulating this one. So what we need to do is select initial, then first of all the bottom boundary, then select displacement or rotations. So the bottom one I will fix. Perfect. So in the y directions, right? So it is fixed in the y direction. I will name it bottom. Done. In the y directions. Okay. Then at the sides, so I will call it side walls. Continue. So side walls are this and this sides. So how to select that? Select. Okay. Now you see my both outer faces are selected. I will call it sides. Done. Then in x direction it is fixed, right? Okay. So now my pipe is fixed, so I will call it fixed pipe. So for the fixed pipe, you can see here that the pipe, one end of the pipe is fully fixed. Okay, so now I have to pull my soil, all the soil elements. So how to do that? Create soil pooling. Go to displacement, rotation, go to save. So already my all soil domains are selected and name as soil section. So continue in the z directions. So now it is fixed all the soil nodes for the whole elements, but I need to pull it, right? So I will call it soil pooling soil pooling step. Then sorry. So I in which step? In pooling step, right? So soil pooling step, for example. Continue. Soil nodes Z3, right? So I will pull in Z directions at 120. The previous amplitude 1 I will use. Okay. So my soil will pull in Z directions for 120 millimeter. Okay, so yeah, everything looks good. Bottom is fixed. Sidewall perpendicular direction is fixed. Pipe end here fixed, and the side nodes good. So I think everything is fine. I have created steps interaction is okay, load is fine, mesh is fine, everything looks good. Now I have to go to jobs and create. I will call it model 1. Continue. I have no subroutines for this problem, so I need not to import anything here, and I will use multiple processors for. Okay. So, but before submit to run, I will check my data. So click data check and wait for a couple of seconds. Because we'll check that everything is fine or not. Then you have to click on submit. So in the next video, we will try to cover some processes in the post-processing. Thank you. Yep, so check is completed. Now submit. Okay, so it will show running. Running. Then after some time, the status will be completed. Then you are good to go for the post processing. Thank you.